Hello, this is the fourth and final recording about the classical techniques in machine learning. It's about ensemble learning and random forests. A group of predictors is called an ensemble of predictors. For example, you can train a group of decision tree classifiers, each on a different random subset of the training set, and you get an ensemble of classifiers. To make predictions after you train this ensemble, each one is trained individually, you obtain the predictions of all the individual trees, of all the individual predictors, then predict the class that gets the most votes out of these individual predictors. Such an ensemble of decision trees is called, has a special name, it is called a random forest. In general, you can get a strong classifier from a collection of weak classifiers. If each classifier is a weak learner, weak classifier, meaning it does only slightly better than random guessing, the ensemble of these weak learners can be a strong learner, achieving high accuracy. Usually, you get this strong classifier if the weak learners are trained independently and are independent of each other. Here is an illustration. First, you need to train multiple diverse predictors. Here we have 4 predictors. When we have a new instance, we give it to them and we get 4 predictions. Usually we do a majority vote, and the ensemble prediction is the majority vote of these 4 votes, and the majority here is 1. Here, how we can do ensembles using Scikit-Learn. Here we have 3 individual classifiers. Logistic regression. This is not a regressor. This is a classifier. Random forest classifier and SVM classifier. We create 3 models from these 3 classes. Then we use the voting classifier class. Voting classifier class is from the ensemble collection of Scikit-Learn, and we give it the list of estimators. We have here 3 estimators: the model for logistic regression, the model for the random forest classifier, and the model for the SVM classifier. Voting, we have 2 options. Here we select hard voting, which means that the prediction is according to the majority vote. Another option is voting equals soft, predict the class with the highest class probability. Now this is an ensemble of classifiers that has 3 classifiers, and we train it as usual. Here we test it. We have here a loop to test the 3 individual classifiers and the ensemble. We train each one of them. We predict the classes for the test set, and we print the results, the name of the classifier and the accuracy score. The logistic regression achieves about 86%. The random forest classifier achieves about 90%, and the SVC achieves 89%, and the voting classifier is better than the 3 of its components, and it achieves more than 90%. Now to 2 techniques to make ensembles, debugging and pasting. We can use the same training algorithm the same type of classifier for each predictor, but we train this algorithm, we train each predictor on a different random subset of the training set. So same algorithm, but the individual predictors get different random subset of the entire training set. There are now the bagging and pasting when sampling is performed with replacement, like when you take some random subset to train one predictor, then and return this subset back to the training set. This method is called bagging, which is short for bootstrap aggregating. When sampling is performed without replacement, when each predictor gets its own disjoint subset of the training set, the ensemble or the method to make the ensemble is called pasting. For both cases, the aggregation function is the most frequent, usually is the most frequent prediction, which is hard voting. This is for classification. For regression, we usually take the average of the individual predictions. Here we illustrate bagging. There is a bagging classifier class in Scikit-Learn. We're going to use it to make an ensemble out of the decision tree classifier. Here, the bagging ensemble has 500 estimators, 500 decision tree classifiers. Each one will take 100 samples. This is with replacement. Bootstrap equals true. This is with replacement. This is bagging. If it is false, then it is pasting. And n jobs equals -1 means that the algorithm can use all available cores to train all these 500 estimators, and this is usually to shorten the training time. Now we have this bagging ensemble. We can fit it and use it to predict the classes of the test set. Here is the decision boundary for this bagging ensemble, and we compare it with the decision boundary of the decision tree classifier. Notice that here it is very specific, it is overfitting the data, but here it captures the main trend, and usually this achieves better than the decision tree. Random forests, back to random forests, are ensemble of decision trees trained via the bagging with max samples set to the size of the training set. It means that all decision trees are trained using each of them is trained on the entire training set. But to have different trees, the decision to split the tree in each of the individual tree is picked randomly. So we get trees with random splits. Random forest classifier is an ensemble of classifiers. Here we select that we want 500 individual classifiers. To regularize each one of them, we limit the maximum number of leaves to 16. This is for performance. We train it as usual, and we use it to predict the classes of the test set as usual. By the way, using the random forest classifier in this way is equivalent to using the bagging classifier and asking it to have 500 classifiers of the decision tree classifier. Each one has maximum leaf nodes of 16, but here we specify that the splitting is done using the random option. Here, this is an important thing. Each classifier should have 100% of the training set samples. Bootstrap true to return. This is with replacement, and this is for performance. Now we come to the exercises of the classical techniques. There are 3 exercises. The first one is to exercise using the SVM classifier. The second one to exercise using decision tree classifiers. And the last one to exercise random forests and ensembles. This is the end of this recording and the end of the classical techniques.